A matrix is something that is written in this form. So I have two big brackets, and inside these brackets I have numbers. So I can have this matrix, so 1, 2, 3, 0. I can have this matrix 3, 1. Now, when I'm talking about the order of a matrix, so the order of a matrix is the number of rows times the number of columns. So for this matrix, I have two rows, so this is the first row and this is the second row, and I have two columns, this is the first column and this is the second column. So the order of this matrix is 2 by 2. This matrix is as well a 2 by 2 matrix because I have two rows and two columns. While this matrix is not a 2 by 2 matrix. It is a 2 by 1 matrix because I have two rows and one column only. So it is a 2 by 1 matrix. Now the first matrix operation is addition and subtraction. Now there's a condition that is I can't add or subtract matrices unless I have the same order. So matrices of the same order are added or subtracted by adding or subtracting the corresponding elements in each matrix. So before doing the addition or subtraction of the matrices, I have to check whether the order is the same or not. So for this matrix, the order is 2 by 2 because I have two rows and two columns, and for this matrix the order is 2 by 2 as well because I have two rows and two columns. Now I can add the two matrices. Now I have A plus E, so the answer is A plus E. B plus F, I get B plus F. C plus G, I get C plus G, and D plus H, I will get D plus H. The second matrix operation is multiplication by a number. So each element of the matrix is multiplied by the multiplying number. So if I have W times this matrix, so I have to multiply W by each element or each number inside this matrix. So W times A is WA, W times B is WB, W times C is WC, and W times D is WD. The third matrix operation is multiplication by another matrix. So before doing this operation, I have to check first the order of the matrices. So this matrix, its order is 2 by 2, and this matrix, its order is 2 by 2. So to multiply these two matrices, the number of columns of the first matrix should be equal to the number of rows of the second matrix. So the number of columns, which is this number, should be equal to the number of rows of the second matrix, which is this number. Now, if these two numbers are equal, then I can multiply both matrices. If they differ, then I can't do this operation. So to multiply the two matrices, first I multiply the first row by the first column, then the first row by the second column. Then I go down and I multiply the second row times the first column and the second row times the second column. So let's multiply the first row times the first column. So A times W and B times Y, I add them together and I will get AW plus BY. Then I multiply the first row by the second column, so A times X and B times Z, I add them together, so I will get AX plus BZ. Then I multiply the second row by the first column, so C times W and D times Y. I add them together and I will get CW plus DY. And finally, I multiply the second row times the second column, so C times X is CX and D times Z is DZ. Now, in this example, I have to perform the following operations. So the first operation is the addition of matrices. So I have the first matrix, which is 2, negative 4, 3, 0, and the second matrix, which is 3, 5, 2, 7. Now before doing this operation, I need to check the order of each matrix. So the order of the first matrix is 2 by 2, and the order of the second matrix is 2 by 2. Now since the order is the same, I can add the two matrices. So 2 plus 3 is 5. So I write down here 5. Then I have negative 4 plus 5 is 1. So here I have 1. Then I have 3 plus 2, which is 5. So here I have 5. And finally I have 0 plus 7. And the answer is 7. Now in part B, I have 3 times 2 negative 1 and 1 4. So I have to multiply 3 by each element inside my matrix. So 3 times 2 is 6. 3 times negative 1 is negative 3. 3 times 1, so 3 times 1 is 3. And 3 times 4 is 12. So this is my answer. Now in part C, I have this matrix, which is 3, 2, 4, and 1, times this matrix, which is 2, 1, and 1, 5. So first, I need to find the order of each matrix. So this is a 2 by 2 matrix, and this is a 2 by 2 matrix. Now I have to check the number of columns of the first matrix and the number of rows of the second matrix. If they are equal, then I can do the operation. So the number of columns of the first matrix is 2, while the number of rows of the second matrix is 2. So both are equal, therefore I can proceed with my operation. So let's recall. First I have to multiply the first row of the first matrix times the first column of the second matrix. Then I multiply the first row times the second column. Then I go down and I multiply the second row times the first column and the second row times the second column. So first I multiply 3 times 2, which is 6, and 2 times 1, which is 2. So 6 plus 2 is 8. Then I multiply the first row times the second column. So 3 times 1 is 3, and 2 times 5 is 10. So 10 plus 3, the answer is 13. I go down to the second row and I multiply the second row times the first column. So 4 times 2 is 8, and 1 times 1 is 1. So 8 plus 1 is 9. And finally, I multiply 4 times 1, which is 4, and 1 times 5, which is 5. So 4 plus 5 is 9. So this is my final matrix.